assignment that you received in class to hopefully help you better understand the differences between quieter or softer, louder waves and sound waves with higher or lower frequency. So let's start with number one. It says, how does a wave pictured on an oscilloscope show loudness? So when we're talking about loudness, we're talking about volume. Volume is determined by how tall the wave is. So we're talking about from there until there. That distance is the amplitude. I like to think of the word amplitude starts out with the word amp. And an amp or an amplifier makes things louder, or you can adjust the sound on an amplifier. So the higher the amplitude, or the taller the wave, the louder. So that's what you could write for your statement. The taller the wave, or the higher the amplitude, those are the same things, will produce a louder sound. Has nothing to do with the pitch. You can have a very low pitch that is very loud, or you could have that same low pitch that is very quiet. So this is talking about loudness, amplitude, how tall the wave is. The next one is talking about how does a wave pictured on an oscilloscope show pitch? And then you're supposed to look at these pictures and to form your hypothesis. Well, this one says, it's kind of hard to read, but it says high frequency, high pitch, low frequency, low pitch. So what that means is the number of waves. If I count these waves, 1, 2, 3, 4, 5, 6.5. This one has 6.5 vibrations per second, or we call that hertz. And this one has 1, 2. Because this one has more vibrations in the same amount of time, this one has a higher frequency. So frequency, or pitch, is determined by the number of waves per second. Higher frequency, more vibrations per second, higher pitch. And vice versa, lower frequency, fewer vibrations per second, and lower pitch. Okay? And then the bottom oscilloscopes you had to answer some questions about. So let's look at that. I'm not sure where that stripe right there is coming from, but just ignore that. Number 3 asks, which wave is both soft? So soft, remember, if we look back up, soft would be shorter amplitude, shorter height, and high-pitched. So high-pitched, remember, is lots of waves, or more frequencies per second. So I'm looking for very short and many waves. And the only one that really fits that description, it really stands out to me, is number 5. It's very short, so the amplitude is smaller than all the others, and it has the most number of waves per given of time. This is a view of 1 second. Which wave is loudest? Again, going back up to the top, louder means taller, so we don't care anything about the frequency at this point. We just are looking for the tallest wave, and clearly this one is much higher than any of these waves. So it would be number 4. Number 5 asks, which wave is the highest pitch? And we really already answered that when we answered number 3, because this has the most vibrations in this given amount of time. Each one of these is a view of a second. It has the most complete vibrations, up and down movement. 1, 2, 3, 4, 5.5. Okay? So that would be number 5 again. Number 6, which 2 waves have the same volume? So you're looking for 2 waves on these oscilloscopes that are the same height, or have the same amplitude. And the only 2 that have that are 1 and 2. Notice that one goes, that crest goes up to there, the crest goes up to there. Okay? So that would be 1 and 2. Number 7, which 2 waves have the highest pitch? This one's a little trickier because you actually have to count the number of waves, because pitch, again, is determined by the number of waves per second. So if I look at this, I know that this is the highest. I know that this is probably the lowest. So I'm going to focus in this area. I'm going to count 1, 2 waves. This one is 1, 2, and a little bit more, so that's not exactly the same. And this one is 1 and really closer to 2. So I think 2 and 4 would be the best answer there. The closest to having the same frequency, which would then make them the same pitch. This one will be much louder than this one, but in terms of frequency, they are the same. They have the same number of waves or vibrations per second. And then for 8 through 12, we just have to count the number of waves given in these oscilloscopes to determine the frequency. So what is the frequency of 1? 1.5 hertz. What is the frequency of 2? 1, 2. 2 hertz. What is the frequency of 3? 1, 2, and maybe a quarter. So 2.25 hertz. Number 4 we said was the same as number 2, so that is also 2 hertz. And the frequency of 5, 1, 2, 3, 4, 5, and 1/2. So 5.5 hertz. 13, what is the frequency of the wave below if it is, or if it was, a view of 1/100th of a second? Okay, so we want to know what's the frequency. We have to count the number of waves, so let's count them. There's 1, and there is 2. So there are 2 pictured here, but if this is a picture of 1/100th of a second, we have to actually multiply that times 100 to get a frequency of 200 hertz, or 200 vibrations per second. Okay, so if hopefully this is helpful. If you have questions, make sure you speak up in class, ask questions, come see Mrs. Smith or myself, and we'd be happy to go over it again. Have a great day, and we'll see you next time.